Hi guys, this is Mrs. Tellas. This is a video for a part of 6.1 in section 6.1. We're going to be doing the zero exponents in this section on this video and the negative exponents in this video as well. Here we go. All right, so this is review. 5 to the second power means 5 times 5, which is 25. And 10 to the third power means 10 times 10 times 10, which is a 1 with 3 zeros. See how the number of zeros match the exponent? That's because our number system is based on 10. And then 4 to the fourth power is 4 times 4 times 4 times 4. Now, I don't know that one by heart, so I'm going to use my Desmos calculator. So I go here and I type in 4, and I put the A to the B is the exponent button, and then to the fourth power. And that gives me 256. So it's 256. And same thing here, 8 to the third power. I don't know that by heart. I know 8 times 8 is 64, but then I don't know what the other 8 is. So I'm going to type it in. 8, A to the B to the third power. And it's 512. So 512 is my answer. So I'm evaluating each of these. I'm coming up with an answer. All right, so for categorize, I would probably put the ones that have 0 power together. I would probably put the exponents that are negative together. And the ones that are positive together. That's probably how I would sort them. I mean, there are other ways. You can't get this wrong. It's a form of problem solving. But that's kind of what we're doing today. We just did some positives. We're going to do 0 next and then negative last. All right, so we're going to use our calculator, and the parenthesis buttons are very important here. So if I have a parenthesis button and that negative is on the inside, I have to put it on the inside. The parentheses are down here. This is in my way. Here we go. So I do parenthesis. I don't remember what the number was now. -7. So -7's inside the parentheses, the second parenthesis, and then I raise it to the second power. And that's 49. Okay, so you press stop and go through and type these into Desmos and come up with each one. So this one's -256. If you stopped and did what I asked. This one's -1 with 5 zeros, so -100,000. I knew it'd have 5 zeros because of the 5. And this is -36. So I'm hoping you typed those into your calculator. Okay, type them in exactly like they are, including the parentheses. All right, so here's our first rule. Any non-zero value to the 0 power is 1. Okay, so if it's a base of any number other than 0, and it's to the 0 power, it's 1. So each of these are 1. And if you ever forget, you can type it into Desmos. If it's a number. Now, if it's not a number, if it's a letter, you have to remember something to the 0 is 1. So these over here are like little PEMDAS problems. So there's like a -1 outside. So -1 times 1 is -1. Or, since they're numbers, you could go to Desmos and type it in. So that would be negative parenthesis 2 parenthesis exponent 0. And it would give you the answer, -1. So the calculator is definitely going to be our friend during this unit. So this is -1 times 1, which is -1. Because 4 to the 0 is 1. 2 to the 0 is 1. All right, so any negative power, so we need the word negative here. This cord's in the way. There we go. Can be evaluated by moving the base and exponent to the opposite part of the fraction. So I like to think about the fraction as bunk beds. Okay, so this isn't a fraction, but I can make it a fraction by putting the 1 on the bottom. This is the top bunk up here, or the numerator, and this is the bottom bunk down here, or the denominator. And what I notice is that it's got a negative exponent, which is -2. It is unhappy because it is negative and it's got a negative exponent. The 7's not negative. The exponent is what I look for to be unhappy. So if it were on the top bunk and it was unhappy and I was babysitting, I would try to move it to the bottom bunk. Maybe it's scared up there. So if I move it to the bottom bunk, now it's happy and I can evaluate. So 1 over 7 to the second is 1 over 49. Okay, same thing with the 2. Again, it's unhappy. I can tell it's unhappy because it's in the top bunk. And I can tell because it's negative. It's got a negative exponent. So I move it to the opposite part of the fraction, which is down here, the bottom bunk. 1 over 2 to the 5th, which is 1 over 32. And the last one's a letter. So let's use red. So again, it's on the top bunk. I can tell because it has a negative exponent. So I want to move it to the opposite part of the fraction. So I move it down to the bottom. And now it's happy. And I can't evaluate that because I don't know what A is. So these two are evaluate. And this one should have the directions of simplify. So when it's unhappy, I move it to the opposite part of the fraction. So if it's on the top, I move it to the bottom. And if it's on the bottom, I move it to the top. The top bunk is like the numerator. And the bottom bunk is like the denominator. Okay? All right, let's try some of these. So we're going to circle whether they're happy or unhappy. We're not going to do the problems. We're just circling whether they're happy or unhappy. So you can tell from the exponent, is this happy or unhappy? Well, it's unhappy. I would have to move it down to the opposite part of the fraction, which is in the bottom. Hey, this one's happy where it's at. I could just stick that in the calculator. Hey, this one's happy where it is. It has a positive exponent. It's happy. I could just stick it in the calculator. And this last one is unhappy. It has a negative exponent. So I would have to move it to the opposite part of the fraction, which is on the bottom. And then it would make it happy down there. All right, so this time we're going to simplify using the powers. Because there are no letters here, we really could just stick this in the calculator, but I'm going to do it without the calculator. But if there are no variables, I really can just stick it into Desmos. So this is -4 times -4, which is positive 16, as there's two -4s. This one is two 4s with a negative in the front. The reason that the negative is not squared is because it's not in a parenthesis. Only the 4 is squared. So this is -16. These are both happy. I did not move them to the denominator. I just evaluated them. This one is unhappy. I can tell because it's got a negative exponent. So I turn it into a fraction like a bunk bed. And since it's unhappy on the top, I move it to the bottom. So this is 1 over 5 squared, which is 1 over 25. And same thing here. He's unhappy. I can tell because he has a negative exponent. So I make it a fraction, and I move it to the bottom bunk. So 1 over 3 to the second is 1 over 9. That's my answer. And you can use the calculator for the power if you want. That's totally fine. No decimal answers, please. All right, so now we're going to throw in some letters. Okay, and what you have to do is you have to think about each of these as their own little problem. Okay, so if I look at this first one, you've got a 5, you've got an a to the third, and you've got a b to the -2. So the only one that's unhappy is the b. The 5 and the a are perfectly fine where they are, so we're going to keep those there. The b is going to go down to the bottom, so it's going to be b to the second, and now it's happy, so it's the answer. Okay, so look at this one. Y is fine on the top bunk. X is not fine. I can tell because it has a negative exponent. So if it's on the bottom bunk and it's crying or unhappy, I would move it to the top bunk. So x to the 5th, y is the answer. Okay, on the next one, which one is unhappy? Well, I hope you said n was, because n's got the negative exponent. He's unhappy on the bottom, so we move him to the top. 5a n to the third. Notice 5 and a have exponents of 1. They're not unhappy. They're perfectly fine where they were. Okay, let's look at this one. We've got two unhappies here. This one and this one. A to the 4th is fine on the top. He stays. 2 to the 2nd goes down to the bottom, and b to the 3rd goes down to the bottom. 2 to the 2nd, we all know, is 4. So my final answer looks like this. So first I made everything happy, and then I evaluated 2 to the 2nd. All right, let's look at this one. We've got a -3/4, which are perfectly fine. They have exponents of 1. They're happy. The only one unhappy is this A. Everything else is fine where it's at. So I keep the negative 3/4, I keep the C to the second, and I move the A to the fourth down to the bottom. This is my answer. All I'm doing is looking at them individually. That's all I'm doing. All right, there's some more. I want you to press pause and try these. See what you come up with. See what you come up with. All right, so if I look at the first one, the 4 stays and the B stays, and the C goes down to the bottom because he was unhappy. Okay, so if I look at this one, T to the 0 is 1, and S to the negative 3 is unhappy. So we move S to the 3 to the bottom. And then since there's nothing up there, we just put a 1 in its place. And we really don't need this 1 in front, but we can keep it. Okay, negative 12, x to the 0. Well, x to the 0, this part, anything to the 0 is 1. This is negative 12 times 1, which is negative 12. Here, the 2's unhappy and the y's unhappy. The 9x is perfectly fine where it is. I'm not moving that. So the 2 to the second's coming down to the bottom, and the y to the third's going up to the top. So 2 to the second is 4. So 4 times 9 is 36. The x stays, and the y to the third stays on the top. These are both unhappy. So the 2 is going to go down to the bottom, and the 3 is going to go up to the top. So 3 to the fourth, 2 to the third. 3 to the fourth is 81, and 2 to the third is 8. That's the answer. I hope you're getting them. I hope that it's becoming a little easier for you. Let's look at these. 5 is fine where it is. 10 is fine where it is. Both of these are unhappy. We're going to switch their places. So 5 and 10, a to the fourth goes to the top, and m to the negative 1 goes to the bottom. Now, 5 over 10 can be simplified. 5 over 10, a 5 goes into 5 once, and a 5 goes into 10 twice. So my final answer is 1a to the fourth over 2a to m. And I really don't need the first power. I can put it, but I don't need it. I also don't really need this 1. I can put it, but I don't need it. This is my answer. Last one. C is unhappy. So we move C to the top. So this is AC squared. I think that's the last one. Oh, I have more. Well, look at this one right here. Very interesting. Look at all of that on the inside, but all of it is raised to the 0. And I don't care how complicated it is. If it's all raised to the 0, the answer is just 1. All right, Brandon says the 2 expressions are equivalent. Is he right? Well, let's look. We've got 2 unhappies, this one and this one, so we need to switch them. So A stays on the top, C to the third goes to the top, and 7 to the second goes to the bottom. I put the C on the top and the 7 on the bottom. So let's see, that would be A, C to the third. I just put them in alphabetical order, and 49 on the bottom. That is not what Brandon got. What we have is right. Okay, so he forgot to move them. You can't evaluate a negative exponent. So he forgot to move them before he evaluated them. All right, so you're going to go, I think we're going to do a worksheet over this to give this a try. So go ahead and get the worksheet from Mrs. Tellas, or go online and get the worksheet and do the work on a piece of paper. Okay, then you'll take a picture of either the worksheet or your work and submit that on Canvas for credit. Thanks very much. Have a good day.